Okay, let's begin. For set A for your study guide, we have add 15.3, 1.1, and 1.7 using mental math. Since 15.3 and 1.7 are compatible numbers, they are easy to calculate mentally. So you're going to use the commutative property, which means you can change the order of things to add the numbers. So for example, 15.3 and 1.7, we do them out of order and get 17, and 17 plus 1.1 equals 18.1. So how are we going to use mental math for a number question like problem 1? Well, for problem 1, I'm going to add 8.6 and 1.4 together. 8 and 1 is 9, and then the 6/10 and 4/10 is another 10, so that would be 10 plus 23.4, or 23 and 4/10, equals 33 and 4/10. For number 2, we have 27 minus 9.9. So in my head, I could do 27 minus 10, which is 17. But what did I do when I did that? I over subtracted by a tenth, right? So I'm going to add a tenth back because I over subtracted, and that gives me 17.1. For the next problem, I see compatible numbers for number 3. 13.5 and 36.5 added together, it's going to be the same as 13 plus 36 is 49, plus the 2 halves. So 39 plus 1 half is 40. So this would be 40 plus 5.7, or 45.7. And for the last one, we have, do this one in blue, 205.4, 205 and 4/10, minus 99.7. Well, in my head, I'm doing 205.4 minus 100, which gives me 105.4, okay? But by subtracting 100, I over subtracted by 3/10, so I'm going to add 3/10 to that and give me 105 and 7/10. Okay, so compatible numbers help us do problems easy mentally. All right, on this page, set B, it asks us to use compatible numbers to estimate. Remember that compatible numbers can give us a good estimate for rounding. So, for example, I look at this and I say, okay, nice compatible numbers. Well, if I round these to the hundredths, okay, I get 400 plus 300. Okay, this is a little bit of a round. So 400 plus 300 is 700. Okay, now I haven't looked at the answer key yet, but there's a chance they use 360 plus 290. There's a chance. I don't think they did, but you never know. But these are once again just to get estimates. So 36 and 29 added together would be 36 plus 30 is 660. But that's too much. So 650 is an approximate. I'm guessing if I look at the answer key, they use this one right here. All right, this one is about 15 minus about 4. 15 minus 4 is 11. Once again, we are estimating in this section. We're not actually answering the actual answer. Here we have 80 plus, this is about 3, so 80 plus 3 is 83. All right, and I should really put that these are approximately equal to, All right. Here we have 25,003 minus 12,900. Okay, I would say this is about 25,000 minus about 13,000. Okay, so the answer is going to be about 0, 0, 0. 5 minus 3 is 2. 2 minus 1 is 1. About 12,000 is the answer here. All right, for this next section, they want you to use the place value blocks. Okay, so for example, 1.86 is one whole, so that's one whole, and then there are 8/10. If you take a look, 1, 2, 3, 4, 5, 6, 7, 8/10, and then 6/100. 1, 2, 3, 4, 5, 6/100. That's where 1.86 or 1 and 86/100 come from. Well, they subtract away 95/100 from that by taking 1, 2, 3, 4, 5, 6, 7, 8, 9/10, and 1, 2, 3, 4, 5/100, right? So 90/100, 9/10, and 5/100, leaving us with, what do we have here? 9/10, and this 100th right there, 1, 2, 3, 4, 5, 6, 7, 8, 9/10, and 100th, or 90/100. How would that work for us? Okay, so for the first one, 2/100 would be two of these. This is me doing number one right now. 2/100, and then 89/100 would be 1, 2, 3, 4, 5, 6, 7, 8, and then 9 more of these. 1, 2, 3, 4, 5, 6, 7, 8, 9/100. Oops. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 10 and 11. All right. We already had 2 there. When we started, we had 2, and we added 9 more. That gave us 11. So together, that means I have 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10. This whole thing that I'm about to circle in purple is another 10 pieces, so that would be 9/10. Write that down. 9/10 plus 2/100 left over, 0.02, or 90/100 plus 2/100, which is 92/100. Now, obviously, these are a little bit harder to do. I have a little device here that allows me to count, but you could draw these out if you wanted to. So let's try one more this way, and then we'll do a couple more. All right. So what do I have here for number 2? Let's erase some stuff, shall we? Okay. Edit. Clearing from page. Let's clear these away. Oops, cleared off too much. Delete. Delete. All right, so for this one, we already had 92/100 as our answer. So I have 67/100, and I'm taking away 31/100. So let's do 67/100. So this will be number 2 that we're working on. So 67/100 would be 1, 2, 3, 4, 5, 6/10, and we have 7 of these. Let's do 1, 2, 3, 4, 5, 6, 7/100. So 67/100, and we're going to take away, get rid of, I'm just going to cross them out, 31. So 1, 2, 3/10, 31. What does that leave me with? I will circle that in yellow. It's kind of hard to see. what does that leave me with? It leaves me with 1, 2, 3 tenths, so 30 hundredths, or 3 tenths. 31, 32, 33, 34, 35, 36. So 6 more hundredths, or 36 hundredths. So the answer to this is 0.36. All right. I know that this takes a lot of drawing, and I have pieces that are easy for me to find, but you could do the same on paper if you wanted to. For the next piece, we have 34 hundredths plus 34 hundredths. So I'm going to do a little trick here that I can do, but you can't. 30 hundredths, or 3 tenths, plus 1, 2, 3, 4 more hundredths. And I need to add that to itself. I should say that I'm working on number, still in green. I'm working on number 3 now. So 34 hundredths plus another 34 hundredths would be to just clone this, so double it. All right. So what does that give me? It gives me 1, 2, 3, 4, 5, 6 tenths. So 0.60, 60 hundredths. And 1, 2, 3, 4, 5, 6, 7. Ooh, I forgot to copy one more. So I'm going to kind of draw that in. There you go. 60 plus 8 hundredths is 68 hundredths, 0.68. All right. And the last one, which I'm going to show you now, the last one in this section, would be, remove this. I'm going to remove these. And I'm going to remove all but this one. I'll show you why I'm doing this in a second. Okay, so this is going to be for number 4. I'm doing number 4 right there. That's kind of hard to see. Let's call that number 4. All right. So number 4 is 81 hundredths minus 78 hundredths. So this is 10, 20, 30, 40 hundredths, 50 hundredths, 60 hundredths, 70 hundredths, 80 hundredths, and 1 left over. And I need to remove 78 of them, right? So if this is number 4, I'm 81 hundredths. 1, 2, 3, 4, 5, 6, 7, 8 tenths, or 80 hundredths, plus 1 hundredth. And I'm going to remove 78 of them. Well, that means I get rid of all of this, 30 hundredths, 40 hundredths, 50 hundredths, 60 hundredths, 70 hundredths, and I'm going to get rid of 71, 72, 73. Let's slow that back a little bit. Oops. 71, 72, 73. Let's see, this is what happens when you're recording. Let's make that smaller. 71, 72, 73, 74, 75, 76, 77, 78, leaving me with 3 of these hundredths. I know I kind of wrote it a little bit too close, hard to see, but this is what I have left over. 2 down here and 1 more, or that's 3 hundredths left over. Let's go on to set 4, subtract, use place value blocks to help, or let's just do it the traditional way. So for number 1, okay, 7.06 plus 0.85, I'm going to just add 6 plus 5, 11, carry the 1, 1 plus 0 is 0, plus 8 is 9. Put my decimal place down, 7 plus 0 is 7. This is 7.91, or 7 and 91 hundredths. Let's do number 2. Number 2 would be 24.07 minus 5.316. Okay, my decimal place is lined up, but what happens is I have a 0 here that, is not shown. So 7 hundredths is the same as 70 thousandths. And now, subtract 0 minus 6. Can't do it. I need to borrow and regroup. So that would be 10 minus 6 is 4. 6 minus 1 is 5. 0 minus 3, can't do. I need to regroup. So that would be a 3. This would be a 10. 10 minus 3 is 7. Put the decimal point in. 3 minus 5, can't do without regrouping. So that becomes a 1. This becomes 13. 13 minus 5 is 8. Remember, I put my decimal point down before. And 1 minus nothing is 1. So this comes out to 18.754. Okay? Let's look at the next one. 51.92 minus 28.003. Okay. All right. So I need to add a 0 here to get the place values to work together. 0 minus 3 is something I can't do. I need to regroup. So that's a 1. That's a 10. 10 minus 3 is 7. 1 minus 0 is 1. 9 minus 0 is 9. Decimal point comes down. 1 minus 8 can't do without regrouping, so that becomes a 4. This becomes 11. 11 minus 8 is 3. 4 minus 2 is 2. This one is 23.917. Let's go on to the next one, number 4. I'm looking at the clock. The bell's going to ring in about 9 minutes. Let's see. 8.71 minus 0.4. Well, to get the decimal places to line up, I'm going to put a 0 in there. 1 minus 0 is 1. 7 minus 4 is 3. Bring my decimal place down. 8 minus 0 is 8. This is 8.31, or 8 and 31 hundredths. Let's make our 8 look a little better, shall we? 8 and 31 hundredths. Okay. For number 5. For number 5, we have 98 plus 3.79. So that would be 98.00 plus 3.79. 0 plus 9 is 9. 0 plus 7 is 7. 8 plus 3 is 11. Carry the 1. 1 plus 9 is 10. So this one comes out to 101.79, or 101 and 79 hundredths. Let's look at number 6, shall we? Talia measured 2 strings. The green string was 2.3 centimeters long. The blue string was 4 centimeters long. How many centimeters longer was the blue string than the green string? So this is a subtraction. So we're going to subtract 4 centimeters minus 2.37. Well, to get the decimal places to line up, we would put 2 zeros in here. So 4 is the same as 4.00. Now, can I subtract 0 minus 7? I cannot. So I look to this place value, I have another 0. So keep going. This 4 would become a 3, which allows us to regroup this 0 to a 10. Now that it's a 10, we can regroup here. So this becomes a 9, and this one now becomes a 10. 10 minus 7, 3. 9 minus 3 is 6. 3 minus 2 is 1. So it's 1.63 centimeters longer. All right, now let's look at set E. Set E is as follows. Remember, think about these questions to help you model thinking habits. How can I use math I know to help solve the problem? How can I use pictures and objects or an equation to represent the problem? And how can I use numbers or words and symbols to solve the problem? So remember, a good model clearly shows the quantities in the problem, how the quantities in the problem are related. Alberto ran 15.6 kilometers on Monday, 15.6 on Monday, 12.8 kilometers on Tuesday, and 6.5 on Wednesday. Dennis ran 11.25 on Monday, 14.6 on Tuesday, and 8 kilometers on Wednesday. Who ran farther? Well, to figure out who ran farther, we would add 15.6 plus 12.8 plus 6.5, and this would give us Alberto's number. For this Dennis, it would be 11.25 plus 14.60 plus 8.00. Okay, so let's do some adding. Let's start with, this is Dennis. So let's add up Alberto's number. 6 plus 8 is 24. 6 plus 8 is 14, plus 9 is 23. Carry the 3. Carry the 2. 2 plus 5 is 7, plus 2 is 9, plus 6 is 15. Carry the 1. 1 plus 1 plus 1 is 3. So Alberto ran 35.3 kilometers. Dennis, let's see what he ran. 5 plus 0 is 5. 2 plus 6 is 8, plus 0 is 8. Put the decimal point down. 1 plus 4 is 5, plus 3. 1 plus 4 is 5, plus 3 is, I need to slow down. I'm looking at the clock, it's my problem. 1 plus 4 is 5, plus 8 is 13, carry the 3. And now I have 1 plus 1 plus 1 is 3. So Dennis ran 33.85, okay? So how do we find before we solve? We add them together, add each person, write an equation to model this problem. So the equation would be 15.6 plus 12.8 plus 6.5. Put that in parentheses. Subtract from that 11.25 plus 14.60 plus 8.00. That's these three numbers added together for a total of 60. So the difference between them is 35.30 minus 33.85. I know I'm running out of room. And see this clock right here? At 8:49, class is over, and I need to teach, so I got to finish this quickly. 0 minus 5 can't do, so I'm going to regroup. 10 minus 5 is 5. 2 minus 8 can't do, so I'm going to regroup there. That becomes 12 minus 8 is 4. Put the decimal point down. 4 minus 1 is 1. So what happened? We had Alberto ran 1.45 kilometers more. I hope that helped. Thank you very much. Be well.